Okay, so hello everyone. It's already 12:30, but let me see if there are any questions before we start the Java topic. Did anyone like, yes, did anyone had a chance to look into the example we, or the exercise we gave in the last lecture? Did anyone have a chance to look into the last lecture anyway? The slides at least? No, not the Hammock distance in tutorial. This is a different one, Gautam. Like in last lecture, we had also an example that I asked you to think about. Let me look into the last lecture and let you know which one. We had one example in about like bitwise manipulation, and there was a second one on the slides, but we didn't discuss. I asked you to think about. Let me open my slides here. Example 2, I guess, Rookie, that's correct. Okay, so yeah, anyways, I look into these things. This is a good example of how, as I said before, and maybe Java is a fresh start for everyone, in case you kind of someone has fallen in following the flow of the lectures. So the lectures are building on top of each other. I mean, until we started C, and also in Java, you will see that most of what we have discussed in C we didn't lose in Java. But the point is, during the lectures, there are many examples. So almost there is no single concept in the lecture without a clear example. The way I would study these is I would first make sure I understand the concept and then try to code the example myself and look into the solution. And then also, if there is any example that is not solved, I would think how to solve it, right? And then maybe seek help if I wasn't able to reach a good answer. After doing this and solving the labs, again, you will be ready for the final, right? Okay, so let's now jump directly into Java, because this is a long lecture. I don't want to waste too much time on that. But do you know when you are going to upload the previous lectures to YouTube? Cassandra, by tomorrow. So all the lectures are there except for the last lecture, if I remember correctly. So last lecture, today's tutorial, and today's lecture, hopefully by tomorrow morning, they should be in. Okay, Java. As we said last lecture, today we are starting Java, the other programming language, the other half of this course. And the purpose of the first lecture is to give you the context, right? What is different from C to Java? What is the mentality? What you need to care about? And what puts you in track to write your first program, right? In Java, we have yeah, we are using Eclipse. It's almost the same environment. And with regard to the environments, let's discuss this during tutorials and lab time. In lectures, we more focus on the concepts and examples themselves. But yes, generally, yes, Eclipse is mainly, in fact, a Java IDE. To run C, you need an additional toollet chain, which you guys have done in Lab 0, but Java can run out of the box. Okay, so what I was saying is, what today's lecture purpose is to put you in track to start writing your first application in Java. Very simple application, but some context here. So what is Java? Why people even need another programming language? Some of the few things, given that this might be, I know it's your second programming course because you had Python in first year, but based on my experience, let me assume this might be your first real programming course. So some of you might even have the questions, why we have so many programming languages, and aren't they all doing the same thing? And hopefully in today's lecture, by comparing C and Java, you will see that no, they are not doing the same thing, and every programming language has its own use case. Some programming languages are more famous or more commonly used than others, and this changes from years to years. I mean, 10 years ago, maybe C was the most used programming. You can look into this history, and many sites provide you with this history. Recently now we have Python. Before Python, we had Java as the most common programming language. I believe now it's Python. So let's see. So Java is, compared to C, is, I would say, a younger programming language. So it's developed by Sun Microsystems. I guess you are young enough not to witness Sun, because in maybe 2008 or 9, it was acquired by Oracle. But Sun was one of the biggest chip manufacturers and computers designers in the world. And they developed the Java programming language. And Java, as I said, is a younger programming language that was proposed in 1995. So it's very recent compared to C. And it's still one of the most popular programming languages. And it has some kind of features that are very unique to Java and the Java mentality, as we will see during this lecture. So maybe an interesting question, not technical one. So really, what is Java? Does anyone know what does Java mean? Not lava with J, Nicole. No, that's good. Coffee, that's correct. Yeah. So it means coffee. And Java, so for example, in Arabic, given that my mother tongue is Arabic, so in Arabic, coffee means kawa. So it's more close to Java. And some refer to it as also the island in Indonesia that is Java. And maybe some of them say that this is a source of the original source of coffee, but generally Java means coffee. And if you look into the symbol of Java, you would really realize that. So if you look into the symbol, you will find the Java symbol is like this cup of coffee, right? So the reason they called it has nothing to do with any technical feature of Java, or it keeps you awake or anything. It's just they met in a coffee shop and then they had a different name. They found that there is a programming language with this name, which is, so they said, let's propose another name. We are in a coffee shop, let's call it Java, right? So this is a bit of funny history here. So why Java? So Java, compared to C, is an object-oriented programming language. One of the main concepts you need to learn in programming is OOP. C lacks this ability, and this is one of the main limitations of C. Well, C has its own use case, so not supporting OOP is fine for the use cases that C is used in, for example, microcontrollers or embedded systems with low-end, as we have seen, fine-grained control of the memory, for example. So you don't need OOP in these kind of applications. But object-oriented programming mentality, and this is one of, maybe it's, if you choose one thing to learn from this part of the course, it should be the mentality of object-oriented programming, because focusing on Java is one thing, but the mentality you get from the programming is a completely different thing. If you learn OOP in Java and you understand the concepts behind it, which some will find challenging, if you got questions in the meantime, please ask during all the coming lectures, as we usually do. But the point is, if you learn object-oriented programming concepts, I don't know, inheritance, pick anyone, classes. If you pick this one and learn it well in Java, you can apply it in any other programming language, because it's a way of thinking, it's a mindset, right? And one way I would like to have this course, or a feature of this course different than other programming courses, is to think more in the mindset rather than the actual syntax and details of write like a certain algorithm A or B, right? Getting the mindset is really what is important, because from my experiences, if you know the mindset, sometimes I need to write a piece of code in my research or when I was in industry, but I don't know what language to use. But I have the idea and I have the mindset. I search for a programming language that serves this mindset. I find it's Python, Perl, whatever. I don't know this language. I look for an example anywhere, Stack Overflow or something. I start putting an example together and then I end up with my code. So if you have the mindset, anything else is really can be acquired very easily, right? As far as you know how to program, how to think about a problem, and what are the capabilities that you have in your hand, which is OOP is one of them, right? The other advantage, Java is very robust. We will see now what we mean by being robust, and is highly portable. Why is highly portable? Because in Java, again, as we will see in details just in a few minutes, it's not like C. In C, you need to compile your program, have an executable or binary, the exe file that you generate, and this one is specific to your operating system and hardware. For example, if you have your friend with a Mac OS, with an Apple hardware, MacBook, for example, and you have a Windows OS using an Intel machine, take your binary, the executable, give it to your friend. He will not be able to run that. Why? Because the generated executable is specific to the hardware and the operating system that you use in your machine. Java is facing this limitation by saying, I have an intermediate result that you can run in any machine and in any operating system. Good. So it's very highly portable. You can write your program not caring at all about the hardware, and then you can give your code to anyone and is able to run. Good. One thing that you will find good about Java is the syntax is very similar to C. So all what you learned in C, you can carry forward with some exceptions that we will discuss to the Java syntax. So you will not find a barrier of having a syntax in a syntax problem in Java, because it's very similar syntax to C. Some of you, and I really do agree with you, that kind of say why we study two programming languages while we can just see, for example, C++ with OOP and low-level pointer programming. And as I said, I do agree with that. But one advantage I find in using two programming languages in a course is somehow resembles the real use case. I mean, if I give you one programming language and you go out in the outside world and you find you need to learn another one, well, this might be an effort. If I give you two, you might need to learn a third one, right? So there is no one correct number of programming languages to know. The important thing is the skill. So by shifting from one programming language to another during a course, and thinking of the differences, this might give you some skills to learn, to learn other programming languages that you didn't touch in your undergrad, right? So think of how I take the transition, and you can apply this to any other programming language. So how Java works and why it's portable? Because Java, as we will see, it has a compiler similar to the GCC compiler, for example, in C. It's called Java C. It converts a Java program into an intermediate representation, intermediate language, Java bytecode. So this generation step is common for any operating system and is common for any hardware. Then you take this bytecode, and there is another Java tool, which is called Java Interpreter, that translates it into the specific machine language in your machine. And this is why you need to install the Java virtual machine. Remember in Lab 0, one of the steps that you needed to install Java JVM to be able to run Eclipse. Why that's the case? Because Eclipse itself is programmed in Java, and it needs the JVM to run, because any Java program needs the Java virtual machine to run, right? This is why you needed to install JVM in your machine in Lab 0. So Java virtual machine is a virtual machine that can execute the Java bytecode, and simply by having this intermediate layer of JVM, you can take any bytecode and translate it into your specific machine code or assembly. This is a bit of a detail. I need to jump into the figure. But before this, there are two types of programs for Java. One of them is called the Java application. The other one is called Java applet. The main difference is Java applet runs from the browser. And usually the way it works is the program itself resides in a server. And then you open the browser and you execute the client, which is like us as users, execute this program in the server. We will never touch this thing. And by the way, Java is not JavaScript. These are two completely different programming languages, right? For some of you that might wonder. So Java applets have the ability to run in servers, but we don't do Java applets at all. What we write is Java application, and a Java application runs from your own machine, right? So it's very similar to the C in that sense. Okay, before I take questions, I see many things going on in the chat. Let's compare the C mindset with the Java mindset, or C philosophy with the Java philosophy. So we had this exact slide, I guess, in the second lecture of C, if I remember correctly. And we said you take a C application, any application you write any, like, I don't know, hello world.c, for example, and it has to go through all these steps to be able to generate at the end the executable and run it in your machine. You have to do the preprocessor, which, for example, if you remember, takes all the header files, replace them with the actual code, and take any defines and put it with the actual value. And then this is still a C code. It has to go to the compiler, which what you do in the build, by the way, this is the complete build process you do. Until here, this is done by Eclipse build, right? And then the compiler gives you an assembly code in form of instructions, add, subtract, etc. And then this goes to an assembler that gives you an object code that you link with multiple object codes. For example, in our lab, we have the test cases files, and we also have our main development question files. This all has to be packaged together into a single application. So we have multiple object files Finally, you combine them and you generate a single executable file that once you run, this is now the run process. So this is the build process. This is the run process in Eclipse. Once you run this application through Eclipse or just double click it in your operating system, it runs, so it gets loaded into the memory through the loader, and then it gets executed. Good. So we have explained this in a very detailed, I guess, half a lecture in C. How this compares to Java, the main observation that Java is making is all of this process is really machine dependent. What it means is that to generate a specific assembly, you need to know whether you are using an Intel processor, an AMD processor, an ARM processor, or whatever processor you are using, in addition to what operating system you are running as well. Good? So it's machine dependent, which means your same application, to be able to run across different machines, you need the source code, right? Which really is not something good, because if you ask a developer to write you a program, he shouldn't be giving you the source code, because that's a copyright of him. He should give you also only the executable, right? So, but the problem is, what if you want to run multiple machines? You need really the source code. So it's not very portable in that sense. In the other hand, the Java philosophy or mindset is, I have this intermediate step. So I have a Java program. This can be anything here, with just hello world application. I feed it to a compiler. This compiler does not give me the assembly code. On the other hand, it gives me an intermediate representation, which is unified across all hardware and operating systems. And then afterwards, what comes next is the JVM, the Java Virtual Machine, which when you install for a specific machine, takes this bytecode and translate it into the specific machine code for whatever OS or hardware it is. So by putting this intermediate result, you don't need the source code, but you only need the bytecode, right? Which is the intermediate representation. So now we have different stages. We have the compilation stage, which takes the Java program, run through the Java compiler, which is like Java C. It gives you the Java bytecode, right? Which usually is in the file name .class. It's called class, right? You will see this when you run something in the lab, for example. And then the second stage is, this stage is exactly the same across all your operating systems. You don't need to install something different to be able to get the Java bytecode. The second stage is what is different, or what is tailored for the OS and the hardware. So you take the Java bytecode, and then it runs through an interpreter that gives you the specific machine code. This machine code can be for Unix if you're running a Linux, can be for Windows, can be for Apple, can be for Intel machine, AMD, ARM, whatever, right? So far, is there any question? Let me look into this chat. Okay, many things, but I don't see any question. Yanhao, doesn't C header acts a kind of class? No, C header is only connecting multiple source codes together, but it's not in the form of a class. Once we know what is class, Yanhao, you will really see how C is not like doesn't have classes. The closest thing in C for classes is structures, as we have discussed in the structures lecture. Are they? No questions. Okay, good. So a bit of like chat here. Good. So a bit of it. So until now, this is a mindset. So if you get it, that's perfect. Now I'm just presenting it in a different way to let you know what you really installed in your machines. So we have the JDK or the Java Development Kit. It has two things, some development tools, and this is similar to the C tool chain you installed, right? So this has the compiler, the interpreter, etc. And then we have the JVM itself. You can think of the Java Virtual Machine as a sandbox, something that is runs on top of your hardware to emulate as if you have a different machine. If some of you already are familiar with VMware or these virtual machine tools that you can have an operating system on top of your own operating system, JVM is applying the same idea. You create as if you have a different operating system inside your own running operating system. So it creates this sandbox where it has a set of libraries, some classes, and other files, and it gives you the bytecode. Good? Good. So now let's see, as we have done in the C case, we start with the simplest Java program and try to break it down step by step to understand how to write a Java program. So this is, I don't know, like 5 lines of code or 3 lines of code for a first Java application. And what we are doing here is we are only printing my first Java application or hello world, or you can write whatever you want to write. The first observation is this Java application has to start with this public class thing, right? So the rule is, this tells you how to run things, but simply let's just forget about this for now. Yeah, so starting from the rule. So you have any program, it's not like C, where you have your functions as your unit of writing programs, and you have to have a main. Here, to write a correct program, you have to have at least one class, and this class has to be like one class at least has to be public, right? So here we define a public class, my first application. This is the name of the class. You can call it anything as far as it's a valid name. For example, you don't start with a special character. Usually the convention is you start with a capital letter, and it has to be public class, like that. At least one class has to be public. Class is the reserved word that is saying I'm defining a class right now, and we have a detailed discussion later about classes. And public means it's accessible by others, and also this is called identifier or keyword for now. Later we will discuss what are the different possibilities of having class: private, protected, etc. But to be able to run a very simple program, write it and run it, you have to have at least one public class. And this class, the second condition, has to have at least one main, not at least, it has to have only one main function, similar to the condition we have in C. You have to have one main, you cannot have two, and you cannot have zero. You have to have one main in your program. In this case, we call it a public function. We define it as static. Forget about static for now. This is going to be discussed later. And is void. A question, and this is information you know from C. Why I define the main to be void, or what does it mean? When I say void function, no output or no return, that's correct. So that means now I'm not returning anything from the main. If you look here, there is no return at all, right? And then these are the inputs. Usually in Java, functions are called methods, right? So the word function is not used in the Java terminology. It's called method, but it's the same thing as a function, right? So the main method here returns nothing, so it's void, and it takes some input arguments, right? So it takes some input arguments in a string array, right? By the way, we have never done this in C, but in C you can do exactly the same thing. You can take input arguments to your main from the user or from the screen, right? But we didn't do this before. So it's okay to take, these are simply the input parameters that you can configure your program. Here we don't use them at all, so just forget about them for now. And then the actual body of the code itself, which is this line, a single line. This is completely equivalent to say printf with a new line in C. So breaking it down, println or print line is something that is printing on the screen, so it's a printf, but it has the new line at the end, right? So you are printing this message in a single line, and then you break the line. Why do we do system.out.println? Because anything in Java is organized as classes, and when you call a function, you need to go first to the class that has this function and then call the function. So system.out is the Java internal or helper class that has many of the functions. One of them is the print line. So by saying system.out.println, I'm going to the system library out class, and then I'm using out of this the print line method, not function, because it's called method in Java. Good. Is there any question? Any questions? I'm just stopping for 30 seconds to see if there are questions here. We don't need to specify the library. Yeah, include something, right? I will, when you have the complete like file, I will show you this, but usually you do. And how to import libraries and these things also, I guess, will come into this. Yeah. Okay, good. If you want to create a class, do I create it inside this main class? No, you don't create a class inside a class. We'll see now if you have multiple classes how to do this. I mean, one file, one program can have multiple classes, but they have to be out, right? It's print line for now, Nicholas, but we have different print functions. So we'll see right now how to use print line, printf. All of this is already in Java, right? One thing that we have here, which is again is inherited from C, is having comments, right? The same way you comment code in C, you have these two forward slashes to have a single line of code, or you can have this kind of forward slash and the asterisk like between two to have multi-line comments. It's the same thing as in C. Good. So similar to C, if you have, I don't know, 100 classes in a program, multiple functions, when you run this program, again, the hardware will start executing everything from the main. This is similar to any programming language. You have to find a point to start with, right? And this is usually the main. So again, when you execute this, the hardware will start, or the program counter of the program will be pointing to the first line of the main. And again, this is similar to C. So in Java, I guess Nicholas was already pointing out into this. We have been using the print line. We also have only the print. The difference between print line and print is print line adds by default the new line specifier at the end. So you simply, once you finish your text, you jump to the new line by default. Print only prints those characters. So if you print something else afterwards, it will be in the same line. Good. Let's see another maybe a little bit more involved example in Java when we want to add two integers together. So I write a class that I call add integers. And then in this case, what I want to do is I want to read two integers from the user, from the screen, add them, and then print out the result to the screen, right? To deal with the screen, usually we use a class called scanner in Java, and someone was saying Stogie.h. I was going to ask this specific question. Here, this is the first time we see import. The import here is similar to the include in C. So you are telling the program you need this helper file or header file or this class in the Java terminology, which means you're going to use some functions from this class. Good. And then this is the name of a class, add integers. It has a main. I want to ask the user to input two integers. Printf and scanf, they are also included in the out, but generally to scan something from the user as an input, you need the scanner helper or header file or class, again in Java terminology. So here I'm defining an object of the class scanner. And this is somehow different mentality than C, because in C, I can directly call the function because there are no classes in C. While in Java, to access the functions or the methods of this scanner class, you want first to create an instance of this class or object of this class. The way to do this is to say, here I'm defining a variable called input, call it anything, X, Y, Z. It's a variable of type scanner. And then new scanner is basically declaring it. And system.n means I want this to take something from the input screen for the user, not from the file, for example, right? So what you are doing in this line is just simply define a variable or object of that class to be able, of the scanner class, to be able to use the functions of the scanner, right? Later, I'm defining my variables, the two input ones, num1, num2, and the output that I'm returning. Then here, I want first to tell the user, please input two integers for me. So I use the system.out.print line, enter two integers. This is for, we have seen this in the previous slide. You simply are printing a message on the screen to instruct the user to input two integers. Now I want to read them. Previously, I would have written this using printf and then use scanf to read, right? Scanf now is replaced by this scanner class, which we defined as input. And one function inside the input, given that I know now what to read, which is an integer, I would say, please read from the screen a next integer, which means now input would have a pointer at the beginning of the class, read an integer from the screen. Good. So input.next integer is simply going to read an integer from the screen and place it into num1. And then afterwards, I can do the same thing for num2, do also a next integer. And then I want to add them, and finally I would print this sum on the screen. Here, you would see that we have used the printf function, which is very similar to the C terminology. That means now to print things in Java, you have really multiple ways. You have the print line, you have the print, and if you want to format things similar to the C terminology, you also have the printf, right? All of these are useful ways of doing stuff. This is one thing. The second thing, again, is scanf is now replaced by this way of reading from the screen using the scanner class, right? So you define your scanner class, and then you use functions from the scanner class. Here is next int because I'm reading an int. If it's double, next double, or is character next character, right? So it has many helper functions that tells exactly what you want to read, right? Any question? Yeah, what is string arguments thing in the main? So this sometimes, and again, this is also a way that you can do in C, but we have never done. Sometimes when you run your executable, you want the user to provide some input from the beginning, not even through a scanf, but while running the program or executing it. This is usually called input arguments to your program. And the way to do it is main, both in C and Java, can take input as a string of characters where you can interpret as input arguments. We have never used in C, and until now, we didn't use in Java. So I would say ignore it for now, right? But this is basically how it works. What is next int? Ian, good. So if you do it in C, you would do scanf, and then you would have to put the specifier. You would do this, scanf. And then you would say, I want to read an int. And then you would read your int here, num1, right? And it has to be and to be able to write it. So this thing is what tells the hardware that you want to read an integer from the screen, correct? Now, an easier way of doing this in Java is just to use the function that is specific for integers, which is nextInt, which is telling the hardware, I want to read from the screen an integer, right? So simply, this is how you read from the screen. Let me see if there are other questions. Is there still a new line symbol like, yeah, Karina, exactly like here, you see it here, right? If you want to format things using printf, you have all, usually the regex or special I would say character specifiers in C. In fact, these things are not C, the new line, the tab, and the space, these things are across all programming languages, right? So you can still use them if you want, right? Okay, good. So this is explaining the program, all what we discussed. So let me see before we move to something else. Salah, if you did scanner input 1 to 3, you will say num1 equal input 1 to 3. Yeah, input is the name. That's okay. That's a good point. So in order not to be confused, you always have to differentiate between a variable you defined and the actual class. The actual class is the scanner one. Here, input is a variable of this class. As I said, I can call it x. And instead here, I will say x.nextInt, x.nextInt, right? So later when we discuss classes, objects, x is called an object and the scanner is the class itself, right? And basically the object name, you can think of this as any variable name, but instead of being of any type like int double, it's of type class, which is scanner in this case. Ahmad, yeah. So what is new? New is creating an object of this class, and the new, I would say leave this for now. I will come into it when we discuss arrays and classes. So don't bother too much about the new for now, right? It just creates, as your colleagues were answering, you are creating an object, and to create an object in Java, you need to specify the class name and use the new reserved word to really allocate this in memory, right? Good. So primitive data types in Java, they are very similar to C. We have bytes, short, int, long, and like they have the same meaning and semantics and length in C. We also have float and double. Maybe the difference that we have here is characters are no longer only 8-bit or 1 byte. They are 16. And I guess I told you also that some of the recent C versions, they have the character as 16-bit, but by default it's only 8. So here is 16. The second main difference is here we have an inherent or primitive type that is called Boolean. In C, we didn't have a Boolean type. It was mainly an int, and we dealt with 0 as false. Any non-zero value is true. Here we have a specific type called Boolean, and it takes true or false, right? Here are some examples of immediate values or literals. If you do this L thing, this is similar to constants in C as well. If you do L, it's a long. If you write it down in the floating point representation, it's double. If you write F at the end, it's float. You can also represent your double floating points as like the exponential, right? Magnitude and exponent. You also, this is similar to C. This is a character. Boolean is true or false. Good. No new information here. Arithmetic operations exactly as C, so I'm not going to discuss them. One thing is all the arithmetic operations of like, so here int has different things, like similar to C, we had int, unsigned, character, short, byte. When you do an operation, arithmetic operation in any of these types, by default, they are converted to int. So the result is an int. For example, if I define something as byte, byte is nothing other than an int of only 1 byte. And then if I do addition, although x and y are bytes, the result is int. So if I want to keep it to be int, I would have to cast. Casting is exactly the same as in C. You just write the type you want to cast to between brackets. Good. And we will come into casting right now. I'm just not throwing new information. It's something that we already discussed before. So casting, can someone remind me what was the rule in C? So if you do operation in, for example, int, and you want the output to be float, so what is the rule we had? What are the rules of casting? Do you remember? So simply we had two different things. Casting from narrower, I would say 3 things, but the third one is really doesn't work. So the narrower to the wider type, and we had the wider to the narrower type, and I will give you examples now. And then we have something that cannot be casted to something else, like incorrect casting. Good. So narrower to wider. For example, something is float and I want it to be double. So I would say, let me say the following. I would have float x double y, and later I would say y equal x. X here is float, which is narrower than the double, which is wider. Is this correct in C? And do I need to cast? Or how it operates? What is the rule? Cast to larger set, makes the larger range. That's all what you guys are saying is correct. So simply, if you are casting from the narrower to the wider, this happens implicitly by the compiler. You don't need to specify, right? So it happens by default. So here, the value of x will be casted or extended to the type double by default, right? While moving from wider to narrower, you need to specify the casting, otherwise it wouldn't work. If I do the other way around, you would have to say x equal float y. So casting from the narrower to the wide, sorry, from the wider to the narrower, you have to cast yourself. Good. Here, if you have done this, it would still be allowed. It's in fact a better programming practice to do the casting yourself explicitly, right? But what I'm saying is allowed in C not to do that, or also in Java. The same rule, by the way, applies for Java and C. All the casting rules are the same, right? With few exceptions that we will see right now. And then, so the general rule is casting from narrower to wider happens by default. You don't even need to care about. Casting from wider to narrower, you need to specify. And as you were saying in the chat, if I am having an expression that has float and double, the overall result is really for the wider, which is double, right? These are the rules of casting. So let me remove all of that. Give me a second. So again, what is typecasting? For those that don't remember, typecasting is moving from one type to the other type. As we said, the value of the narrower might be assigned to the wider by default without casting. While moving, this is called usually widening, and this is done by the compiler. And this is just what can be casted to what by default. While moving from the wider to the narrower, you need to do the casting yourself. And here what is written is the general rule. If you have an addition or subtraction or any operation or expression that has multiple types, the whole expression is evaluated for the wider type, right? Okay. This is just like listing some of the roots. For example, if you have integer and float in an expression, everything is transformed into a float because it's wider. Anything that has float and double is going to be transformed into double. So just some examples. Good. Operators. And especially the bitwise operators, given that these are the ones that we discussed last time. They are all exactly the same as in C, with one exception, which is we have now, and this is something I would have expected some of you to ask about in the C, although I might know some of you didn't take the digital design course. So let me bring first the problem, confuse you, and then give you the correct solution. Usually in digital design or in bit operation, this is something not related to C or Java. If I have something like this, and I'm telling you this is a sign number where the last bit represents the sign, right? So it has the sign and the magnitude, good? Which means if I want to interpret this sign number, I would take the last bit to be sign. Usually 1 means negative and 0 means positive. And then I would evaluate this value. For example, in this case, 1 means negative, and then this is 8, right? So it's -8, right? The problem with this, if I have done the shifting, similar to what we discussed in last lecture, if I want to shift right, what I would do, I would have to insert zeros here. So let's say I'm shifting right by 1, right? So I'm going to do something like this, shift right by 1. What will result in, I'm inserting a 0, everything else is shifted to the right by 1, and I lost the last 0, right? Doing this, if you look into this number, now we transform this number from negative to positive, right? And that's really problematic. Good. This is usually referred to as logical shifting, which is a shifting that is not aware of the sign. Good. So you have to be aware of that. The shifting that is done in C is logical shifting. We don't have arithmetic shifting in C at all. Arithmetic shifting, so we have two types of shifting. Logical one doesn't take the sign into account, while the arithmetic one takes the sign into the account, the way we will see right now. In Java, this what we discussed last time, which is left shift. This we discussed last time, which is right shift, but we also have what we call arithmetic right shift. This is the logical shifting. On the other hand, if I do this in Java, the result would be, I would look for the last bit, most significant bit, and I would keep the sign. And usually what I do is sign extension. This is referred to as sign extension. So I would instead insert a 1 instead of 0. So it would be 1, 1, and then 0, 0, 0, 1, 0, 0. So here, instead of inserting 0, I would insert 1. The general rule is you would always fill in with the highest bit. If the last bit was 1, you would fill in with 1s. If your last bit was 0, to fill in with 0. Why I would do this? To keep the sign of the number, right? Did by any means you discuss arithmetic versus logic shifting in digital design or not yet? No. Okay, so if you got questions, please ask. So just to summarize, logic shifting always inserts zeros to the left. Here we are only talking about right shifting. Don't bother about left shifting. In right shifting, logic shifting, which is what is only in C, which is this one, with only two like larger than or smaller than sign, it only inserts zeros to the left, while the arithmetic shift, which has the 3 comparison signs or operators, it always inserts what is the last bit. So here I inserted 1 if it was 1. If this was 0, I'm going to insert 0. Good. You will discuss this in detail in digital design. In fact, you would even implement the circuit for those who are taking the course. Yeah, all the precedence constraints are the same in like between Java and C as the slide was showing. Good. So this is one difference between bitwise operators in Java versus C. We have one additional operator, which is called arithmetic right shift. Good. We still have all what we discussed last time, bitwise and, bitwise or, bitwise XOR, and bitwise negate or not, right? So we also have the logical operators, equal, not equal, and, or not. The same syntax as C. They operate on Boolean types, and they also result in a Boolean. Let's take one example. If I'm doing something like this, the same rule applies from C. For logical operators, if your expression evaluates to something that doesn't need the evaluation of the remaining of the expression, you just ignore the other part, right? This is called usually short circuit. Let's take an example. And I guess this is maybe very similar to the example we had in last lecture. Assume here I'm saying 4 less than 5 or something. According to what we discussed last lecture, this always evaluates to true. True or anything is true. Thus, the compiler is really not going to evaluate this expression at all, which means the post increment is not even evaluated. So if initially K was 10, after this expression, K would still be 10. Good. What if I want this to be evaluated? Do you remember what we said in last lecture? So how to do this? If I want this expression to be, well, do it first is one possible way. That's correct. But what if I want to bitwise? Correct. So if I do this in a bitwise operation, so it's not here, but if I do something like this, 4, 5, or K plus 20. In this case, K will be incremented because we said the bitwise OR operates in bit by bit, and the whole expression is going to be evaluated. Good. Something that is different in logical operators in Java versus C, because C didn't have a Boolean variable, so it dealt with all integers as Boolean. So any non-zero value is going to give you true or 1. So for example, in C, if you have done this, can someone tell me what is the output of this expression? Not 56? 0, yes, because not 1 is 0 or false, so it gives you 0. While in Java, because we have a Boolean type, you cannot do Boolean operators on, or logical operators on like a binary, not a binary, sorry. You cannot do a logical operators on an integer expression. It has to be Boolean, because now I give you the Boolean. You only operate on the Boolean ones, right? The same thing here. So this is also a difference between Java and C. This is what we discussed in the previous lecture. This gets evaluated and K will always be incremented. Those assignment operators are all the same from C as well. It just gives you, like, for example, plus equal, X plus equal Y is equivalent to say X equal X plus Y, right? Just a short way of writing things, shortcuts. Good. So any questions so far? Because before we jump into strings. Okay, no questions. Good. So one thing that is very, I would say one of the easy ways of dealing with Java than C. So let me first put it in this way. One of the main differences in the mindset between C and Java is C gives you more control, but it might be hard to deal with because you have the full control. For example, in a string, you need to define your string as a string of as an array of characters, deal with it character by character. So it doesn't give you this privilege of the high-level programming. You guys are aware of Python from the first year. So if you compare dealing with the strings in Python versus C, you might think that C is really not very straightforward, right? Java is higher level than C. So in a sense, it gives you the privilege of any higher level programming language like Python. If you want to operate on strings, you can really just easily concatenate them using the @ sign. This is not possible, and this is also possible in Python, but it's not possible in C. So here, for example, I just good is a string. There is an inherent type called string. So good plus day is going to concatenate them, gives you good day. While in C, you either have one of two options. The first one is to use the string concatenate from the string helper library or header file, or you just write your own string concatenation similar to what you have done in the lab, right? Here in Java, it's just a simple add function. Also, this add function allows you to operate on strings and non-string values. For example, if I add something like the number is plus X, this is also the case in Python. Simply X gets converted to string, and you will get a string as the number is 10, right? Yanhao, what is the range of Boolean in Java? It's either true or false. You can look at it as like just a single bit, 1 or 0, right? So it's true or false. I'm asking because it said is a syntax. I'm just thinking, can I define Boolean equal A15 and then do not A? No, you cannot do this. So no, you cannot cast to Boolean in Java. No, you have to define it as either true or false, right? Okay, so also we have the conditional operator, the same thing in C. I guess 95% of this lecture is just reiterating through what we have done in the C syntax, right? So subscript operator to access elements of an array, similar to C. Here we have the dot operator, which we have seen in the C structure lecture, but we'll be using this a lot because to access the members of a class, remember we have done something like input dot next end in the first example. What is this dot? Is similar to the structure lecture and what you're doing in the lab right now. You are accessing a member of this class, which is an object of the scanner class, and it has a member function called next end. So the dot is the member operator, right? And typecasting is similar to C as well. An instance of more details will come about this later, but simply if I defined input as an object of the scanner class, you can simply check. So instance of gives you true or false. If, for example, I said input instance of scanner, then this gives you true. And the reason for this is input, you really defined it as an object of the class scanner. Why this might be useful? Because later you might want to check what is the type of this object, what is the parent class, right? As I said, more details will come about this later, but simply gives you true or false based on whether an object is declared as an instance of a certain class, right? So here, object 1, instance of object 2, true if object 1 is an instance of class ob2, right? Okay, so I guess it's already 1:20, so we are over time. So I would stop here, and then I would take a few questions, and then we continue next lecture. Thanks, everyone. Question, is 1 is equivalent to true? Like if I say 1 equal true, is the result going to be true or false? No. Integers are not casted to Boolean by default in Java, right? And something that you have to take care of. Equal is a logical operator which has to deal with, let me think, do they deal in integer? Let me go back to this slide. Okay, this is the bitwise ones, and we are talking about the logical ones here. The result is always Boolean, but your question is whether they take an input as Boolean or not. Give me a second. And here, this is a clear example that is telling you it doesn't take int as input parameter. So if you say in your example, you said something like this, true or false or whatever, if you have done this, I need to think about this because I don't remember, to be honest, but I don't think this is going to work because here you are comparing two different types. So they should give you a syntax error. If you do something like 1 equal 1 equal 3, then this is a valid expression because both are of the same type, and this is going to give you false, right? Yeah, Nicholas. Yeah, this is what I was saying, Nicholas. You cannot cast true or from booleans. Yeah, that's correct. If I said 1 and true, well, that result with a true. Yeah, again, Sagnan, this is what I was saying. Yeah, and at the morning, this is also what I was good. So all what I was saying is really you have to have the same type of your logical operator. So I guess the main question was a bit different. You cannot cast from Boolean, but the main question was if you have type 1 generally and the logical operator and then type 2, would this even work or not? Because simply you can have here, this is a valid expression in Java, right? The output of the expression is true or false, but both sides are really int, and that's okay, right? Because you are doing a comparison between two things of the same type. While here in the example that your friend gave, one of them was integer, the other one was, this is or and, it doesn't matter. The other one was Boolean, true or false. Then this doesn't work. It doesn't work not because you cannot cast from or to Boolean. Well, this might be a reason, but it doesn't also work because these two things are not of the same type. So given that Boolean cannot be casted to int, or int cannot be casted to Boolean, the expression is operating different types, and this gives us a syntax error, right? Thank you. Treat Boolean as its own type. That's correct, and those can be compared to its. Yeah, you can compare Boolean to a Boolean. You can compare, for example, if you say true equal true, this gives you true. If you say true equal false, that's false, right? Okay, Moaz. So you always need to compare things of the same type. Yes, or those things that can be casted to each other, right? Sandy, yeah, the summary is Boolean in Java is similar to Python, and in fact similar to most programming languages where you have an inherent type called Boolean. C was a bit of special because C is a very old programming language, right? It's the parent of everyone almost, maybe with the exception of COBOL and some other ones. But simply back then there was no Boolean type, so you had to deal especially with Boolean as an int, right? But in Java, yes, it's very similar to Python and any other programming language. Okay, good. So thanks everyone, and I would see you all next week then.
Excuse me?
Yeah, go ahead.
Can I ask, like I'm still not kind of confident with the Boolean type. What I'm just thinking is, like in Java, can I just do for each statement, for the conditional for the if statement, can I just put a number? Does it by default treat it as a true?
No.
Or
right?
it doesn't?
So, yeah, no, right?
It doesn't.
Yeah, it doesn't convert into Boolean by default, right? Yeah, so
in
it doesn't.
Java.
Yeah, in Java. I'm talking about Java. In C, we know how it works. Yeah, that's correct. But in Java, no. You have to have an expression, for example, inside the if statement that evaluates to a Boolean, right?
Yeah. And also, I have a question with the last part you just mentioned, the instance of stuff.
Yeah, the instance of. Yeah.
I got a little bit miss on this part, so may you please repeat?
Sure.
Again?
Yeah. So the simple thing is, let's start from the beginning. In Java, things are represented as classes, and you need to declare objects of these classes. This is what we have done in the first example by declaring an instance of or an object of the class scanner, and we called it input, correct? So dealing with objects and classes in Java gives us the need to know whether a certain object is created from a certain class or not, right? So input, for example, the one that we created in the example, is an object of the class scanner, correct?
Yeah.
So in this case, if input is an instance of scanner, it gives you true. Because an instance of, what it does, it checks whether an object is an instance of a certain class.
It's a method of any class.
Yeah, it's a method of any class. That's correct. It's an independent of any class. That's correct.
I see.
Yeah.
Also, instance of is like a statement.
An instance of is an operator. You can think of this as an operator. That's correct. Yeah.
Okay.
Yeah. It's a special operator that you need to check the type of your object. Yeah. Good. Yeah. Thanks. Yesterday, we didn't have a lecture yesterday. So Wednesday lecture and today's tutorial lecture will be posted tomorrow morning. If one doesn't work in Java, yes, I believe so. For if statement, for example, could we do something like if true? Yes, Moaz, you can do if true because true is a Boolean expression that evaluates to true. But this if statement will always be taken, right? So it will always be true. That's correct. For the midterm, again, let me say this. I have done this. I have said this already in the tutorial. I might update the announcement. In the midterm, the total mark is 90. We had 3 questions. Every one is 30. And for those questions that had part A and part B, where in part B you need to test in the main, it's usually 20 for part A and 10 for part B. Good. In some rare cases, this depends on the version you got, but it might be 25 and 5, but generally it's 20 and 10. 10 for testing in the main and 20 for the question itself. But all the 3 questions have equal weight of 30. Good. Okay, thanks everyone, and I would talk to you then next week. Not yet, Mark, not yet. Yeah, not yet. Okay, thanks. Thanks everyone. Talk to you later.
Would you mind if I ask one more question?
Yeah, sure. Go ahead.
About the incentive. What I'm saying is if I have 2 classes and each of the classes has one method with the same name, so then what are you going to implement the instance of operator?
Yeah, an instance of doesn't operate on methods. It operates on classes and objects. So for example, assume you have class A, and these things will be discussed much like in more details later. But let's say you have class A and class B. Class A has a method. Let's say I call it. Input is not a method. Now I see what confuses you. Input is not a method. Input is an object you create of that type. So it's not so. Okay, let me go back to the example. Now I see where your confusion is coming from. Now, so let me go back here. Okay, here. Scanner is the class, correct? I guess you already get that. So this is the class itself. Scanner has an internal function or a member function called nextEnt, right? Because here we say input.nextEnt. So this is a function implemented inside class.
Yeah.
Input here is not a function of scanner. It's an object of scanner, right? So I guess now you know what is the difference between object, member function, and a class. So what is your question then?
Oh, I see.
Right?
I see. It doesn't matter with the method. It just check if this object is
exactly. It has nothing to do at all with the member functions. Correct. Yeah.
Thank you.
Yeah. Welcome. Okay. Bye bye everyone. Bye bye.
Bye bye.
I just had one quick question.
Sure.
Yeah. So like just in general, right? Like a Boolean expression, like the way we do them, like for example, like if statements, it's similar to C, but it's just like in C, it'll return like a.
Yeah, so
like
so the
0 or 1, like but
exactly correct. Yeah, that's exactly the thing. Any expression you do very similar to C, except that in C, Booleans there is no inherent type called Boolean, which means that true is evaluated as 1, and it's of type int, while false is evaluated to 0 and it's of type int. While in Java, you also evaluate the expression to true and false, but you really have true and false. So you don't do this last step of converging of doing the conversion from true false to 0 1, right? Does this make sense?
Right. So like we do our logical like expressions, like if statements, all that logic.
Like everything is exactly the same. And I guess the slide I stopped at and what we are starting from next lecture is how to do if conditions, else, while, for loop, all these things.
But it's just that those conditions just return different values.
They return Boolean types.
Boolean, yeah.
While in C we didn't have Boolean. Yeah, that's correct.
Makes sense. Thank you.
Yeah, welcome. Bye bye.
Excuse me.
Sure.
Just one more.
Yeah, no worries.
Yeah,
no worries.
About the level of the Java language, like you say, it has a higher level than the C language. So I'm just thinking, does it has any control on the memory?
That's a good question. We will come into this next lecture. So it doesn't give you this fine-grained control of pointers. There is no concept of pointers in Java. and you cannot allocate and find the addresses of variables and operate on them in Java. No, that's not allowed. So we will come into this next lecture. This is one of the main differences between Java and C. Yeah.
What I'm thinking is, so does that mean I can literally like if there is a program is running right now and it asks me to input an integer and then whatever I input, can it then define an array depend on whatever the input I put?
Yeah,
like
that's
in
correct.
C you can,
Yeah.
right?
Yeah, that's correct. That's correct. But in Java, arrays also, this is going to be discussed next lecture. Arrays have a dynamic, like you can simply just define the size of the array as a variable. So it's not like C. Like arrays in C are static by default, and if you want them to be dynamic, you have to dynamically allocate them using malloc. There is no malloc in Java, but arrays themselves are really can take variable size. Yeah.
Okay. Thank you.
Good. Yeah, welcome. Yeah, have a great weekend, everyone.
You too.
Bye.
Bye-bye.